Hello and welcome to the ESTECO Technology Spotlight. This is Dario Campagna from the ESTECO R&D department. I'm here today with our product managers Danilo Di Stefano and Marco Turchetto. Danilo is the product manager of modeFRONTIER, our desktop solution for process automation and design optimization, while Marco is the product manager of ESTECO VOLTA, our SPDM enterprise platform. How are you doing, guys?
I'm fine, thanks. Thank you for inviting me here.
I'm doing good, thank you, Dario.
Today we will talk about how digital transformation trends like hyperautomation, AI engineering, decision intelligence, and cloud influence the evolution of ESTECO digital engineering software solutions. Let's start from hyperautomation. This is a business-driven approach that organizations use to identify and automate industry-specific processes. With regard to the simulation and analysis domain, the integration and process workflow automation has always been the cornerstone of our technology. Over the years, we expanded its usage to different levels. Danilo, could you tell us more about the continuous maintenance and development of new CAD and CAE integration for modeFRONTIER engineering process workflow?
Yes, sure, Dario. Integration and process automation are very important to be effective in engineering design optimization. In modeFRONTIER, we have a very powerful way of integrating even the more complex tool chains graphically, without the need to script or to code anything. There is a kind of graphical way of introspecting the model that you want to use and to automatically extract the inputs of the model and the outputs of the model. And more than this, you can also link two or more solvers to reflect all the simulations needs for your specific engineering design problem. For what concerns the continuous integration, in modeFRONTIER, you know that we have a lot, let me say, of what we call direct integrations with the most popular CAD and CAE solvers. We are always committed to cover even the latest releases of the solvers that we release as direct interfaces in modeFRONTIER, and we do this by applying a kind of continuous integration approach at development level of those interfaces. That means that we are always and continuously testing even the latest releases of those solvers in such a way that modeFRONTIER is ready to cover them at the release time.
Also, recently you introduced an alternative approach to build the workflow, which promises to improve even more the usability of modeFRONTIER. What is all about?
Yes, it is a new approach to go directly from your model file of your preferred solver to the optimization run. Usually, to do this, in modeFRONTIER, you need to build the workflow. With the guided process, it will be possible to skip this phase, basically. You will be presented directly with the introspection when you drop the node on the modeFRONTIER canvas. The introspection will pop up. You will have just to link the input and output variables of the model with the entities, corresponding entities in the modeFRONTIER workflow. And then, if you want, you can go directly to the planner, where you can define the optimization strategy and then run your optimization problem. In this way, also the learning curve that is usually needed to use effectively and efficiently modeFRONTIER will be reduced in such a way that you will be able basically to skip, the most critical phase, that is the workflow building phase in modeFRONTIER. At the end, a very, very easy way to go directly from the model file to the optimization results.
Marco, is this guided process approach also available in VOLTA?
It will be, in a sense that I really envision the guided process to be in an enterprise environment like VOLTA. And also because the guided process is really the ESTECO answer to the problem of democratization. What I envision is similar to what Danilo said, in the sense that I want to actionate a CAE model directly on the web. So that you as a user will drag and drop a model, and then VOLTA will tell you what are the available inputs and available outputs for that specific model, and then it will bring you to the planner environment, where you will be able to specify any design space exploration strategy that you need to fulfill. So, as I was saying, the democratization is really one of the biggest trends in an enterprise environment. So we want to bring simulation users up into the platform.
All these new capabilities look really nice. Our process automation technology has recently evolved with the introduction of business process management, BPM, capabilities, and is no longer limited to the engineering process workflow. Now users can combine the management of human tasks with simulation workflow automation. Marco, could you explain why BPM technologies makes an impact in the context of an SPDM framework like ESTECO VOLTA Enterprise Platform?
Before getting to the point, I would really like to introduce what business process management is as a discipline. Personally, I love the definition which is given by Gartner. They define the business process management as a discipline that uses various methods to discover, to model, to analyze, and to optimize business processes. And this business process coordinates the activity of people, of information, and data and things to produce business outcomes. So nowadays, all companies have at least undefined processes in place. But at ESTECO, we believe that business process management can really help companies to map, to standardize, and execute engineering design processes. This is why we integrated business process management into VOLTA. Because the final aim is to reuse the knowledge. So once you have your process mapped and standardized, you can execute it as many times as you want, always in the same way. So back in the past, we had the options to choose which was the best standard to use for business process mapping. Our research and development team worked hard in order to select the BPMN 2.0 standard, which is the business process modeling and notation standard, well recognized and maintained by Object Management Group Consortium. So the final aim with business process management in VOLTA is to really improve the visibility and the interaction between the management, the engineering, and the simulation departments. Final goal is really to bring everybody on board and break down the silos.
You mentioned that companies still rely on undefined processes to manage simulation. How does BPM help to address organizational issues and break down technical silos across departments?
Yeah, I was mentioning previously that all companies have at least undefined processes. With this, I mean that more or less everybody in a department knows who is doing what and when. But the fact is that they rely on papers, on emails and phone calls, or even shared drives to pass the data. So they put the models into a shared drives. But with this approach, you will never know if the model that you are working on is in the latest version, is the correct version or not. So those are all common practices nowadays. The point is, the manual task is still performed by a single domain expert. So I was mentioning before that with BPM into VOLTA, we want to break down silos. The reality is that silos are very well present in companies nowadays. So, and then there's also another aspect which BPM can help, which is there is a lot of time which is spent by the engineers and by the subject matter experts to look for the correct data. There's a recent IDC research, a report that says that 30% of the time is spent by the engineers looking for the correct data, which is a huge amount of time. And with BPM approach, we want not only to deliver the tasks, but we want also to deliver the correct data for the engineer to work on. And then there's a problem of visibility that I was mentioning before. Nowadays, SPDM systems or also project management software, they rely on Gantt charts and pair charts, but those have limitations in the sense that with a Gantt chart, for instance, you have an overview of the entire project, but it's difficult at a single task level to understand what are the inputs, what are the outputs, what data was used to perform the task. And so with BPM, we want to overcome these limitations. So with BPM, you can really map a sector of activities, and then the really great thing is that you can execute those processes. So, and also previously I was mentioning that from undefined processes, we can go to standardized processes. So with the BPMN 2.0 standard, you can really map any kind of business process, and you can really standardize it into a business process that you can reuse in the future.
But how do you map and execute engineering design processes in the VOLTA platform? Could you tell us a bit more about the VOLTA Modeler and VOLTA Process Manager environments?
Yeah, sure. So the VOLTA Modeler is a BPMN 2.0 standard editor with which you can map any kind of business process. You can map user task for activity for people, and you can also use the VOLTA service task, which is the activity to call in an automatic way an execution of a simulation workflow. And for this reason, the VOLTA service task is the missing link between the high-level business process and the low-level simulation workflow. I was mentioning before the BPMN 2.0 standard couples a human-readable graphical representation of your business process with an XML encoding. And this XML encoding can be executed by a machine. It means that with the VOLTA Process Manager, you can run those business processes that you mapped with the VOLTA Modeler. Main advantage of this is that the user tasks are delivered to the correct people at the right time, bringing also the correct data to be executed.
And also in modeFRONTIER, Dario, we are going to take advantage of the BPMN standard because we are using this standard to drive the innovation of our proprietary workflow, to drive it toward a kind of standardization. Standardization is a value as itself, because it allows the user to be sure about what each component does in the context of the global workflow. And at the same time, we are using the BPMN standard to extend the modeling capabilities of our workflow. Is a key factor, because it allows our users to be more efficient and to extend the range of the applications that the user can do in modeFRONTIER. We are still not sure if we are going to implement a purely BPMN-based workflow in modeFRONTIER, or if you are simply driving the innovation of the current workflow to be fully BPMN compliant in the future.
To achieve a higher level of maturity in the digital engineering initiatives, companies should not only automate their engineering design processes at different levels, but also make extensive use of artificial intelligence and machine learning to reduce the simulation turnaround time, minimize prototypes, and speed up the whole design process. At ESTECO, we continue to invest in this direction with our extensive library of optimization algorithms and machine learning-based response surface models. In the engineering community, Python is a useful programming language for building engineering applications and facilitating numerical computation. Also, its machine learning libraries enable engineers to elevate their data analysis effort. Danilo, I see that you have progressively built a Python ecosystem in modeFRONTIER to leverage its process automation and design optimization capabilities. How do modeFRONTIER users take advantage of this?
Yes, you are right, Dario. Python is becoming very, very popular between our users. So we decided to put modeFRONTIER in the context of this Python ecosystem, let me say. The idea was to let our users to use their own Python skills inside modeFRONTIER in the most similar way as modeFRONTIER native tools. The first tool that we have introduced a couple of years ago, Python-based, is the PyConsole. With the PyConsole, basically you can post-process all the results that you get at the end of the optimization run in modeFRONTIER design space by taking advantage of whatever Python libraries that you want to use. PyConsole lets you import the data from modeFRONTIER design space tables into a Python environment. And then you can do whatever you want with this data. You can do also the opposite. I mean, from the Python environment, put data as modeFRONTIER native tables in the context of modeFRONTIER design space. Another very nice, I would say, tool, Python-based tool that there is in modeFRONTIER is the PyRSM. The PyRSM lets you train a Python-based RSM in the context of the modeFRONTIER RSM training wizard, with the same parameterization, with the same options, exactly as native modeFRONTIER RSMs. And at the end, in the Explorer of the design space, you get your Python-based RSM available for visualizing charts and whatever post-processing you want to do at the same level as modeFRONTIER native RSMs. Another very useful component, Python-based component, is the PyScheduler. The PyScheduler shares the same concept with the PyRSM, but in this case, it is possible to use a Python-based optimizer, a Python-based scheduler, in the same way as native modeFRONTIER optimizers. In modeFRONTIER, there is a bridge that lets you use your Python-based optimizer at the same level as modeFRONTIER native optimizers. I mean, it will be available in the scheduling project node and also in the planner, ready to be used as an optimization algorithm.
Thanks, Danilo. At ESTECO, making extensive use of artificial intelligence methods also means expanding its usage to a wider audience of CAE engineers. Our numerical team has been working very hard to deliver the autonomous approach to configure our design exploration and optimization algorithms. Could you tell us why the autonomous mode democratizes the use of design optimization and accelerates decision-making processes?
Yes, the autonomous mode is a way to easily parameterize an optimization algorithm in modeFRONTIER. You know, Dario, that parameterizing an optimization algorithm can be a difficult task. So in modeFRONTIER, we decided to release not only the traditional manual way of configuring the optimization methodologies, but also the self-initializing way to configure it. In the self-initializing mode, you have to just insert one parameter, the total number of design evaluations that you are willing to do for your engineering problem. And on top of this, we decided also to release the autonomous mode. The autonomous mode does not require any parameter to be configured. You can just click and run the optimization problem because the algorithm itself is able to understand the internal structure of the problem by applying some machine learning methodologies, let me say, some machine learning-based intelligence inside, in such a way that you get a very good trade-off between the quality of the solutions that you get and the time that is needed to get it. So at the end, you don't need to be an optimization expert to use modeFRONTIER. Your experience in your own engineering domain is enough to be very efficient in design optimization by applying the autonomous mode.
And this is one of the key things for what concerns our technology because, well, VOLTA is based on modeFRONTIER technology. And so for whatever it is from the design space exploration technology from modeFRONTIER is also available into VOLTA. So the planner is available into VOLTA as it is in modeFRONTIER. As planner is not a piece of modeFRONTIER or VOLTA, just it is an ESTECO philosophy to decouple the simulation workflow from the design space exploration strategy that you want to apply on top of it. And the autonomous mode is available into VOLTA 2. And as Danilo mentioned, it is a great time saver. It gives you the best trade-off between the quality of the solution and time taken to evaluate it. So in the end, it gives you the best solution in the shortest amount of time.
And yes, also in modeFRONTIER we have a similar concept, I mean the planner environment. Together with the new concept of the planner environment, there is also a new concept at workflow level, because now we have two different ways of configuring the workflow in modeFRONTIER. The traditional one, where you can define both the engineering process, and on the top of that you can define also the optimization strategy graphically. This is very powerful because you have a single view on both the process and the optimization strategy that you decided to use. Together with this approach, we have released a purely process-based workflow where you define only the engineering process, and the optimization strategy can be defined in the planner environment. One of the advantages of using the new paradigm based on the planner and engineering process workflow is that you can define more than one optimization strategy in the context of the same modeFRONTIER project file.
And to effectively scale up the management of multidisciplinary design optimization studies, you need a state-of-the-art web-based orchestration system. How do you address this in VOLTA?
Well, the scaling up is possible only via web technologies. And VOLTA was made and was designed for scaling up, for lots of users, lots of disciplines, and lots of simulations. I was mentioning before that one of the problems is to bring every team on board on the same platform. The MDO has many different problems. So MDO is multidisciplinary design optimization. The first problem is the collaboration, because you need to have different teams that collaborate with each other and with their own disciplines, so that each team has its own discipline. And then the problem is that the MDO is complex also for the orchestration point of view, because you have many different single disciplines that you should put together, and those single disciplines, they share different inputs, and some disciplines have the outputs that become inputs for other disciplines. And in the end, you should be able to run those disciplines, and VOLTA has a dedicated system for running those very complex MDOs directly from the web.
The planner approach helps to expand the usage of design space exploration strategies. These studies usually generate a lot of numbers which are meaningless unless you give them a proper interpretation. A decision intelligence approach, which uses advanced data analysis and visualization tools, is required to get valuable insights. modeFRONTIER answers to this need with a multitude of design charts and advanced tools for sensitivity analysis, multi-criteria decision-making, clustering, and so on. Danilo, how has this simulation data analytics technology evolved in the latest releases, and which is the direction for the future?
For what concerns data analytics, Dario, the main development driver has been helping our users to manage the complexity of the data that are typically produced by an optimization run. The complexity is not only the number of data, the amount of data that you get at the end of the optimization run, but also the number of variables that you are requested to manage in your workflow by the modern industry, by the complexity of the processes in the modern industry. I would like to mention two design space tools in this context, the sensitivity analysis and the clustering tool. The sensitivity analysis is a very effective tool that lets you to understand the relationships between the design inputs and the responses that you collect from your solver, typically in the workflow. The sensitivity analysis tool is very powerful because it helps you to reduce the size of the problem by exploiting the correlation between inputs and outputs. The clustering tool, at the same time, is very powerful because it lets you to group similar data in similar groups so that you can understand the relationships between the different groups and take advantage of this in the information that you get at the end of the optimization run. For the future, we have already started, by the way, to make more homogeneous the different tools that we have in the design space. Now they have a common UX for the wizard, and in the future we are also thinking to give them a dashboard-based approach. In this dashboard, the user can customize, the user can decide the type of charts that he wants to see to get the better understanding of the data itself.
And you know, in our SPDM platform, usually the design process involves many stakeholders that needs to access the product performance metrics. So in the end, there is the need to share the simulation results. And what Danilo mentioned right now is also available into VOLTA to scale up and to make everybody collaborate on top of the same platform. So that VOLTA was born with the collaboration in mind, and data analytics and post-processing of the data generated during the simulation is a collaborative task too. So in the end, after the run, you would really have to interpret the data to understand it in order to get useful information out of it. And it's the final step to take the decision. So in VOLTA, we have a collaborative web environment, which is called VOLTA Advisor, that allows you to interpret the data, to plot it by means of many different dashboards. You can plot the data, visualize the data in different tables, in charts and radar, or you can also insert notes in order to collaborate with your colleagues and let them understand what you have done during the post-processing. And then lately we introduced also the images and the 3D models. And on this topic, one of the biggest change of the next releases is the 3D model analyzer. The idea is that when you perform the CAE simulations, you should be able to perform the post-processing on the web too, so that with the 3D model analyzer, you will be able to open the CAE model, post-process it, create section planes, and visualize scalar results, vector results, in order to fully understand the model and what the simulation looks like.
Another key aspect to be considered in simulation is the need for high availability of computing resources to reduce the design cycle time. Nowadays, engineers feel even more pressure to produce better design faster. Our state-of-the-art HPC job shadowing technology enables them to maximize the use of IT resources by distributing computational workloads across HPC and cloud environments. Danilo, how does modeFRONTIER distributed execution technology make it possible to streamline the run of very complex simulation processes?
You know that in many optimization studies, heavy simulations are involved. I mean, solvers that require a lot of computational resources to produce the results. To get good results from optimization, you need to perform many simulations. And performing many simulations means to possibly spread the calculations of each design, the evaluation of each design on different machines in such a way, maximizing the hardware resources and parallelizing the calculation. modeFRONTIER supports, by scripting nodes, the most common and most popular queuing systems that you can code in our scripting nodes in such a way that modeFRONTIER will be able to start the calculations on HPC clusters or also on the grid. The grid is a way of distributing the calculation on a local network of machines. So at the end, modeFRONTIER is very effective also in allowing our users to get the results in less time.
Given the web nature of an enterprise platform like VOLTA, the efficient management of simulation requests created by users is crucial. Marco, how does VOLTA distribute the computational workload across different machines, and which are the benefits from an end-user perspective?
Yeah, for VOLTA, it doesn't matter if you have available a laptop, a workstation, an HPC, or even a cloud. What it is important is that the IT department sets up these computing machines and make them available to VOLTA. And then VOLTA will understand and will know what are the available machines and will distribute the simulation workloads across them. And then there is a difference, a separation between the IT departments and the users. The IT is only in charge of setting up the machines, configuring the correct software and setting up the licenses. The end user instead has only to select the proper queue and then submit the job. So in the end, VOLTA will be able to understand which are the available computing machines, and then it will send the simulation jobs to the available machines with the correct software installed and with the correct computing power.
Also, many companies are investing into private cloud infrastructures or using public cloud systems to centralize the management of their application and reduce cost and simulation lead time. Marco, I heard that you added a new cloud deployment option for VOLTA. How can this be beneficial for IT administrators seeking to manage many concurrent users and geographically distributed installations?
Well, VOLTA Cloud Deployment option is one of the most significant changes of the recent years. We introduced this new architecture in order to stay on the edge of technology, also on what the users do not see, so on the back end. And this cloud installation option adds to the standalone one, in a sense that we'll still support the standalone architecture, which is monolithic, which has very good performances for limited number of users, but also uses less resources. We added also the VOLTA Cloud installation option, which instead guarantees best performances for lots of users and also guarantees the scalability, so the elasticity. The application goes up or down depending on the load, and then also guarantees fault tolerance in the sense that since it is microservices based, if one microservice dies, then another one is fired up. And then we want to stay agnostic because we want our customers to be free to choose whatever kind of platform they want and they like. And so this is why we base the architecture on Kubernetes. And this is compliant with the Google Cloud, with Amazon AWS, and with also Microsoft Azure, or even with private clouds like OpenShift.
Hyperautomation, AI engineering, decision intelligence, and cloud-native paradigm are just some of the key technologies that are driving innovation of our digital engineering software solutions. Danilo, Marco, what's on the roadmap for the future? What can we expect from the next modeFRONTIER and VOLTA releases?
modeFRONTIER is an optimizer, so we are working on a new proprietary optimization algorithm that will be available not only in modeFRONTIER but also in VOLTA, with very interesting new characteristics, both for desktop users but especially also for web users. A next topic, it will be related to the Python ecosystem. We have invested a lot of resources in implementing our Python-based tools in modeFRONTIER. We will keep on doing the same also in the future with new, very, very interesting functionalities for what concerns Python in modeFRONTIER. We had always paid attention to the UX of our products. We will keep on doing the same, especially for what concerns the workflow in modeFRONTIER and the design space in modeFRONTIER. For what concerns integrations, we are working on a new plugin-based approach to release our interfaces. It will be not needed anymore to wait for a modeFRONTIER release. You will be able to get your node updated or fixed by a simple plugin approach. You can get the file and load it in modeFRONTIER without the need to wait for the official release. It will be possible to load your preferred Python-based optimizer as a plugin and see it available in the scheduler sections in the same way as native modeFRONTIER.
So on the VOLTA side instead, what we want to bring to the product is first, we want to go a step ahead with security. So single sign-on is one of the most recent topics that we are working on. Then we're going to work on the VOLTA service task, which is what I was talking during this spotlight. And it is the missing link between the high-level business process and the low-level simulation workflow. Then on the guided process, so that you as a user will be able to upload your CAE model, and then VOLTA will tell you that you can actionate it directly on the web. So this goes into the trend of the democratization. We want to have more people on board into VOLTA. Then we are going to push more on the BPM side, in the sense that after we release VOLTA Model and VOLTA Process Manager, we want to improve their usability and also all the features that are available to the two different modules. On the API side, we want to continue the development in the sense that also VOLTA must be an open system, must be able to integrate with other enterprise tools, and we must be able to have an open API.
Thanks, Marco, and thanks, Danilo. We hope you enjoyed this ESTECO Technology Spotlight, and if you did, please share it with others who might be interested in this topic. See you next time.